Alright, in this video here we're going to take a look at graphing a function using transformations of graphs, and this one is going to combine horizontal and vertical shifts of a graph. So a couple different rules put together in a single problem. So I did a couple of videos on, I did one just on vertical shifts of graphs, I did another one just on the horizontal shifts. So if you haven't seen those yet, you might want to check those out before you watch this one, because in that one I go pretty far in depth of explaining what the rules are for vertical shifts and horizontal shifts, and explaining why the rules are what they are to help you get some understanding of the rules. For this one, I'm not going to go that much in depth in it. I'm just going to go ahead and do this problem and show you how to kind of combine those two different rules together in a single problem, or in one single graph. Alright, so the function we have to graph here is f of x equals the square root of x minus 3 plus 4. Alright, so we can see we have a couple things going on here, right? We have a square root, we have an x subtracting 3 from the x, and then outside of that square root we have a plus 4. Alright, so when you are going to use transformations to graph a function, the first thing that you have to do is identify the parent function. Alright, so what's my parent function here? Well, it depends on basically what type of function do we have. Well, the major thing in this function is that square root, right? The minus 3, the plus 4, I mean, those things are important, but that doesn't really distinguish this function. That doesn't really define what's going on with this function. What really defines this function is that square root thing that's in there, right? So the parent function for this is the square root function, right? So again, the first thing you always want to do is identify your parent function, which in this case is y equals the square root of x. Now, I've done a video where I talked about parent functions. I think there were 6 on that video, and I showed you what the graph of each of those parent functions looked like and some of the key points on those graphs, right? And the square root function is one of those ones that I had on there. So if you haven't seen that one yet, you might want to check it out. Just so you know, first of all, what parent functions you're expected to know, and then also what those graphs actually look like and some of the points on those graphs, because we need to know what this graph looks like. We need to know some of the key points so that we can do the transformations and figure out what the graph of this other function looks like. Alright, so in this case the parent function is the square root function because we have a square root in our equation, in our function. Right? Some of the other parent functions were the quadratic function with an x squared. So somewhere in here we had something raised to a second power. Our parent function would be the quadratic function. Right, another one was the cubic function, x to the third power. If somewhere in here we had things raised to the third power, we would use the cubic function as our parent. Another one we did was the absolute value function. So if we had stuff in here inside an absolute value, then the absolute value function will be our parent function. Right, but for this one, since we have stuff inside a square root, our parent function is the square root function. Right, so that's the first step, is identifying the parent function. After that, well, what does the graph of that parent function look like? Right, so the graph of the square root function, and again, if you didn't watch the video I did on the parent functions, you should check it out. But what the square root function looks like is it has some key points on it. It starts at the origin at the point 0, 0. Right, and then it goes to the point 1, 1. And then it goes to the point 4, 2. And then it also goes to the point 9, 3, which I didn't really include 9 here, but I guess I could just to put another point up here. So it also goes to the point 9, 3. Right? The x coordinates on the key points for the square root function are numbers I can take the square root of. Right? The square root of 9 equals 3. The square root of 4 is 2. The square root of 1 is 1. The square root of 0 is 0. Right? So for a lot of the other parent functions, the key points are like -2, -1, 0, 1, 2. That doesn't really work for the square root function. For one, I don't have square roots of negative numbers, so I start at 0. And then, if I try to plug in x equals 2, what's the square root of 2? I don't know. Right? It's not a nice whole number. And so I use key points. I use x values where I know that when I take the square root, I get a nice number. Right? So these are 4 key points on the graph of the square root function. So let me just try to connect those points. I missed that last one a little bit. Let's just put that point up there and pretend that didn't happen. All right, so that's my graph of y equals the square root of x. All right, that's my parent function graph. Now, when you're graphing these functions using transformations, you don't always have to draw the graph of the parent function on your paper in order to do this. But it helps to have a visual image of what that graph looks like. And it really helps for me when I'm explaining to you how to do this stuff to actually be able to refer to the graph of the parent function. But if you know what this graph looks like and you know some of those points on there and you just have that stuff memorized, you can just go ahead and say, okay, well, I do this and this because of these numbers, and then I just draw the graph, and then that's it. You can just go ahead and draw it without actually drawing the parent function every single time. All right, so First step, identify what your parent function is. Second step, know what the graph of that parent function looks like, including some of the key points, the x and y coordinates on that graph. The next thing is to figure out what transformations we have to do to this graph based on the numbers that are in this function and what those numbers are doing. All right, so we have two transformations here because we have two things happening to this square root of x, right? One thing is inside that square root we have a -3, and then the other thing is outside of that square root we have the +4. And those two things are going to do two completely different things to this graph, right? And again, if you have not watched the videos that I did on the rules for horizontal shifts and vertical shifts, you should check those out because those are the types of transformations we have here. And in those videos, I explained it in a lot of detail, right? But if you have watched those videos, hopefully you remember when I have a number added or subtracted inside the parent function, right? In this -3, we say that that's inside the parent function because it's underneath the square root, right? My parent function is the square root function. Anything that falls underneath that square root is considered inside the parent function, right? Whatever is considered inside the parent function is a horizontal shift. If it's being added or subtracted, it's a horizontal shift, right? Now, horizontal means to the left and the right, right? Which makes sense because this -3 is happening to that x value, right? It's x -3, so that -3 is going to affect the x, which is the left and right, the horizontal direction, right? The tricky part of this is it does the opposite of what you would think, right? You would think that -3 would mean move it to the left 3 units, but -3 actually means move to the right 3 units. So it's going to be a horizontal shift to the right 3, right? And again, I did a video where I only talked about the horizontal shifts and the rules for horizontal shifts. So if what I just said there doesn't make sense, watch that video I did on horizontal shifts where I explain why a -3 actually means move to the right 3 units. Right? I'm not going to take time on this video to explain all that again. Right? So the -3 inside the parent function is a horizontal shift to the right 3. And then this +4. Well, if we have numbers added or subtracted outside of the parent function, right? And by outside of the parent function, I mean not underneath the square root that we have here, right? That +4 is not under the square root, so it's outside the parent function. That affects the vertical direction, right? So, inside with the x affects the x, outside of the parent function affects the y, right? And again, in the video I did on vertical shift, I explained why that is, so you can go check that out to get the explanation for it. Now, the vertical shifts up and down make sense. And what I mean by it makes sense is that +4 means go up 4. Right? So that +4 tells us to do a vertical shift up 4 units. All right? So the vertical ones, the ones that happen outside the parent function, make perfect sense. +4 means go up 4, -7 means go down 7. Right? The ones that happen inside the parent function don't really make sense, right? -3 actually means move to the right 3. If it was +7, that would mean move to the left 7, right? But again, if you understand why that is, like, it does make sense when you understand why that rule is what it is, and I'll get into that on the video I did on horizontal shift. All right, so what we need to do now is take every single point that we know on the graph of this square root function and move each point right 3 units and then up 4 units. All right, so that's one way to think about it, is like literally taking this point at 0, 0, moving to the right 3 and up 4, right? And that takes us to the point 3, 4, right? So this point here moves to the right 3, it moves up 4, and then that's where that new point is for this shifted graph. All right, so that's now my new starting point for this function. So that's one way to think about it, is actually sliding the points around it and translating those graphs or translating those points to a new position. Another way to think about it is, well, if I'm moving to the right 3, I take my x-coordinate here, my 0, and I add 3 to it. That gives me an x-coordinate. 0 plus 3 is 3. I take my y-coordinate, and I do +4 to my y-coordinate. 0 plus 4 gives me 4. Therefore, my new point is 3, 4, right? Either way, you end up with a point in the same spot. So it's all a matter of what you're more comfortable with. If you're more comfortable with, well, let me just add and subtract values to these points that I know, do it that way. If you're more comfortable with, let me just move this over and up, and then I'll take this one, I'll move this one over 3 and up 4, and that'll put me up here at the point 4, 5. Right? If you're more comfortable doing it that way, then just go ahead and do it that way. Right? Totally up to you, as long as you get the results correct. Right? So the point 0, 0 translates to 3, 4. The point 1, 1, if I move it over 3 and up 4, it becomes the point 4, 5. the point 4, 2 that I had here, right? If I move that one over 3, that's going to take us to x equals 7. If I move that up 4, it's going to take me to y equals 6. So that's going to be the point 7, 6, right? No, something's not right there. I move it right 3, and I move it up 4. Maybe that is right. Yeah, that's right. Okay, so those are our points there. Yes, okay. For some reason, I thought I did that wrong, but it looks like I did it correctly. All right, so again, think about it as either moving it over and up, or think about it as 4 plus 3 gives me 7, 2 plus 4 gives me 6. All right, and this other one here, the 9, 3, based on how I drew this graph, I can't really move that one to the right 3 units because it's going to be off the board. So I'll just leave that one out for now and just draw what I have here. All right, so I have these 3 points. There's my graph of y equals the square root of x minus 3 plus 4, right? Is the graph of the parent function y equals the square root of x, move to the right 3 and up 4. And when we say move to the right 3 and up 4, literally every single point on this graph gets moved 3 units to the right and then 4 units up to the corresponding point on this black graph up here, which is the transform graph, right? And notice these two graphs have the exact same shape. Right, they're the same shape. They're both square root functions. It's just they're in different positions because in this one here, my x, I had to subtract 3 from the x, and then I had to add 4 on the outside. So that messes up what the numbers are, right? But the shape is the same, right? The relation of these points, these 3 points here and their relation to each other is the same as these 3 points here and their relation to each other. As far as like from this point to this point, I move over 1, up 1. Here I move over 1, up 1, right? It has that same general relationship. All right, so that's combining both vertical and horizontal shifts in one single graph. And when we do the rules of the transformations of graphs, there's a whole bunch of different rules, and any one of them can be put together with any other one in any single equation. So sometimes you have to combine more than 2 of them in order to actually draw your graph. All right, so again, if you haven't seen my videos yet on the horizontal and vertical shifts, make sure you check those out. It kind of explains the underlying reasons for what we did here as far as moving it right 3 and moving it up 4. And then I'll also do videos on reflections of graphs and stretching and shrinking in the vertical and horizontal directions. So make sure you check out those as well so you get the complete picture of all the different transformations that you may need to do when you are graphing functions.